This is Chapter 8, Gas Welding Practice, out of the Welding Practices and Principles book. Okay, and we're going to discuss gas welding. Oxy fuel welding is the AWS accepted term for it. Okay, it's a process of actual fusion between two pieces of steel where they're actually melted down from a heat applied by an Oxy Acetylene flame or an oxy propane or MAP gas, whatever the fuel gas flame, and they're actually fused together to make one part. Okay, we're going to go over a little bit on what makes a good weld, sound weld characteristics, adjusting torches and lighting torches and different flames and stuff like that. We'll start with some weld characteristics, sound weld characteristics. Okay, one of them is fusion. Okay, and fusion is the complete blending of two edges of the base metal being joined, the blending of the base metal and the filler metal being added during welding. Okay, incomplete fusion is a discontinuity, and it may be caused by adding molten metal to solid metal, by lack of fluidity in the molten weld pool. Let's see, it may also be caused by improper beveling of the pieces to be welded, or improper inclination of the torch, improper use of the filler rod, or by faulty adjustment and manipulation of the welding torch. In other words, what's happening is you're basically not fusing the metal together, whether it be the filler metal, the two pieces of the base metal, or whatever. They're just not joining together. You're more or less putting the metal down on top of the surface without fusing it. Okay, another characteristic that you're looking for is penetration. Okay, and what that is that's the depth to which the base metal is melted and fused. Okay, some joints require full penetration, which means it will be penetrated all the way through. Some don't. Some require, less penetration for whatever reasons, depends on the joint and the design. Okay, another thing you're looking for is weld reinforcement. That's actually how much weld is built up above the surface of the plate, either on the back side if it's a full penetration weld, or on the top side if it's on the surface side. The cover is what it's called. Okay, usually you're looking for that on a butt joint, or that's where you look at it, is on a butt joint if you're looking at root penetration and root reinforcement, or on any kind of a groove weld on the surface of it, how much penetrate or reinforcement is on the top. Okay, most of the reinforcement is desirable on the root and the top, the cover of the weld, about 1/16 of an inch above the surface of the base metal on both the root and the cover. Okay, now some of the things that you're looking for as far as the satisfactory appearance. Okay, the weld should be consistent width all the way. The two edges should form straight parallel lines. Okay, the face of the fillet weld or the reinforcement should be slightly convex. Okay, the face of the weld should also have fine, evenly spaced ripples along it, and you should see no spatter, excessive spatter, or any scale or anything like that makes it look kind of undesirable. The edges of the weld should be free of undercut. Undercut is a groove melted away at the toe of the weld, right where the weld meets the base metal, usually because of faulty technique. Okay, and you should not see any overlap. In other words, where the filler metal laps right over the top of the base metal without fusing in. Okay, your starts and stops should blend together so that it's difficult to determine where they actually are. Okay, you ought to be able to look at the weld after it's done and not be able to see where you stopped and restarted again. The crater at the end of the weld should be filled. When you get down to the end of the weld, you're gonna have a small hole, kind of an indentation in the plate where the crater is, and you need to make sure you get that full of weld metal, full of filler metal. If it's a butt joint and you're looking for a full penetration butt joint, then you need to check the backside and make sure that it's penetrated through. Hopefully a 1/16 of an inch of reinforcement on the backside is what you're looking for. And that's, like I said, referred to as the root penetration. As far as lap joints and T-joints, the only way to check and see if you've got good root penetration is to actually bend the things and break them. And you can tell there, you can't really tell by looking at them. Okay, let's talk a little bit about the Oxy Soldin welding flame. Okay, there's 3 types of flames. You have the neutral flame, which means that you are burning equal amounts of oxygen and acetylene. Okay, a neutral flame reaches temperatures at the inner cone ranging from about 5,800 degrees to 6,300 degrees. Okay, the excess acetylene flame, also known as a carburizing flame, and that's where you're burning more acetylene than you are oxygen. Okay, and what happens is you get an acetylene feather in your flame. It contains white hot carbon particles, some of which will be introduced into the weld pool during the welding. Okay, it's not a very desirable flame in most cases, and the way to tell, or some of the results of it, it will cause the weld pool to boil and be very cloudy, and the welds will become hard and brittle. Okay, and this flame, the temperatures range between 5,300 and 5,700 degrees, so they're somewhat cooler, 600 degrees or so cooler than a neutral flame. Okay, then you have the excess oxygen flame, and that means you're burning more oxygen than you are acetylene. Okay, and in most cases it's kind of undesirable too. What you're looking for the most part is neutral in most instances. Okay, but there are certain places where a carburizing or an oxidizing flame are desired. I know that oxidizing flames can be used, they're recommended to be used with bronze, brass, chromium nickel sometimes, stuff like that, but very rarely ever with carbon steel or anything else. Let's see, one of the things you'll notice with an oxidizing flame is you'll notice excess foaming in the puddle. Okay, sparking, a lot of sparks flying out of the puddle. The welds will have really poor strength and poor ductility. They'll be really brittle. Okay, and the temperature of that flame runs between 6,000 and 6,300 degrees, so it's about the same temperature as a neutral flame, but it just gives you that undesirable oxidizing effect. All right, now we'll go to setting up some of the equipment, okay? And it's just essential that you know how to set up a portable welding machine, okay? This type of equipment on a portable machine is what's usually used in maintenance shops and things like that for as far as the oxyacetylene welding and cutting goes, okay? It's most of the time you'll see them on a handcart, a 2-wheeled handcart, portable set of bottles, okay? Consists of an oxygen cylinder, acetylene cylinder, oxygen and acetylene regulators, welding torch, oxygen hose, acetylene hose, wrenches, spark lighter, filler rod, gloves and goggles. Okay, now I'll go over the procedure quick for setting this up. Okay, the first thing you have to do is set up your cylinders on the cart. Make sure that they're standing, they're always upright, and make sure that they're secured with some sort of a chain or a locking device to keep them from tipping over. Okay, the next thing you have to do is dust and dirt sometimes will collect up in the cylinder valves. So you have to crack the cylinders open just a slight bit and allow some of the gas to escape and blow those out so that the seats are nice and clean and there isn't a lot of dirt in there. Okay, then you'll attach your oxygen regulator to the oxygen cylinder, of course. Right hand threads. Okay, then you'll go ahead and attach your acetylene regulator to the acetylene bottle. Okay, tighten everything up good. Okay, then you'll attach welding hoses if you're using your flashback arresters between the hoses and the regulators, you can put them on now. We have ours between the torch and the hoses. Okay, and that's the way I would recommend doing it, but everybody does things a little different sometimes. Anyway, attach the hoses to the regulators, and once again, the red hose goes to the acetylene. The red hose and the nuts with the groove cut on the flats of them, those are acetylene. Left-handed threads for acetylene, right-handed for oxygen, green hose for oxygen. Okay. Let's see, make sure there's no dirt or grit in the hoses. Okay, and that can be blown out of there if you have anything in there before you ever start running oxygen and acetylene through them. Okay, then you're going to go up to the torch, attach the green oxygen hose to the oxygen side of the torch. The torch is usually marked with oxygen and fuel is what it'll say. And attach the green hose to the oxygen side, the red hose to the fuel side, tighten them down. All right, once you get everything tight, then you can go ahead and check everything for leaks. Make sure that you haven't got any leaks anywhere. You'll do this by backing out your oxygen and acetylene regulator screws, releasing any pressure or anything that are on the regulator screws. Okay, then you'll open your oxygen bottle all the way and start turning your regulator screw down to where you have somewhere in the neighborhood of 35 or 40 psi on your oxygen regulator. Then you'll turn your acetylene valve on the bottle, 3/4 to 1.5 turns, and you'll crank your acetylene adjusting screw down to where you have 5 to 7 pounds on the acetylene. Remember, never run acetylene, never work with acetylene over 15 psi. Usually 5 to 7 pounds is plenty for just about anything. But anyway, once you get all of those cylinder valves open and your pressures adjusted, then you can go around with a leak detector. Soapy water is what it is. And you can check all of your fittings, all your connections, make sure you don't have any bubbles anywhere. Okay? Okay. Then you can go ahead and select the proper welding tip. They range in sizes. The Victor system, they go from triple-aught up to like a number 15. The smaller the number, the lower the number, the smaller the tip, the less heat it produces. The higher number is a bigger tip, and the more heat it produces. Okay, so you just pick whatever. If you're doing, say, 16 gauge or 14 gauge, you'll probably be in the neighborhood of a double-aught, an aught, a 1, maybe a 2 in there, but they'll be somewhere right in that range. Anyway, go ahead and test pick your tip and put it on, and you just screw them on hand tight. Okay, and then we'll go into adjusting the flames. Okay, once you get the tip installed, then you'll go ahead and crack your acetylene valve open. You light the torch just with a spark lighter, and you only crack the acetylene valve just like a 1/16 or an 1/8 of a turn. And you'll get a small flame. You'll see a lot of carbon sooty smoke coming out. Adjust that up until that black smoke just clears up, and then you can start adjusting your oxygen. Open up your oxygen, and you'll see a feather in the center of the flame, and that feather will slowly come down as you turn the oxygen up until it just clears up into what's called the inner cone, and that's right off the tip of the torch. And when it just clears up into that inner cone, that's a neutral flame. That means you're burning equal parts of acetylene and oxygen. Okay? When you get ready to shut the torch down, make sure that you turn the acetylene off first and then the oxygen. Okay? Okay, let's talk about a couple of things. Backfire, okay? Improper operation of the welding torch or defective equipment may cause the flame to go out with a loud snap or pop. This is called backfire. The torch should be turned off at the valves. Check the equipment and the job to see which of the following causes may be at fault. Some of the causes are operating the torch at lower pressure than is required for the tip size. Okay? Touching the tip to the work will cause it. Overheating the tip, that will cause it. A loose tip or head where maybe it's sucking air in behind, that will cause it. The inside of the tip may have carbon deposits or small metal particles, that will cause it. Okay, just means you got to clean the tip out. Or the seat of the tip may have dirt on it, or it may have gotten nicked, maybe it was dropped on the floor or something like that. And once again, it's sucking air from the backside, and that can cause it. Okay, flashback occurs when the flame burns back into the torch and causes a shrill squealing or hissing sound. Okay, the acetylene valve should be closed immediately first, eliminating the fuel to the fire. Okay, then you can go ahead and close the oxygen valve. And it says never shut off the oxygen valve first. Okay, that gives the flashback an opportunity to seek more fuel. It'll just keep hunting backwards looking for something to burn. Okay, to prevent this, they have what's called flashback arresters, and what all they are is a check valve. And like I said, we put them between the hoses and the torch, and that keeps everything from going back into the hoses looking for fuel. Okay. All right, so when you get ready to close down the equipment, first, like I said, you'll turn off the flame by closing the acetylene valve first. Okay. Once the acetylene valve is closed and the flame will immediately go out, then you can go ahead and close the oxygen valve. Okay. Once those are closed, both of those are closed, then you can go ahead and shut down the valves on the bottles. Okay, shut off the oxygen bottle and the acetylene bottle. Okay. Once the bottles are shut down, then you can go ahead and open the torch valves back up, and that will bleed the gas out of the regulators, out of the hoses, and out into the atmosphere. Once you get all the gas bled off and the regulators read 0, then you can go ahead and shut the torch valves again. And then you can release or take off the tip and release the pressure regulating screws on the regulators. Just back them off until they spin freely. Okay. Okay, after that you disconnect the hoses from the torch, then disconnect the hoses from the regulators, remove the regulators from the cylinders, and replace the protective caps on the cylinders. That's pretty much the procedure for tearing the whole thing down. Let's see. Okay, let's talk about some of the welding on low carbon steel plate. All right, it's common practice to limit the application of oxyacetylene welding to low carbon steel plate with a maximum thickness of about 11 gauge or 1/8 inch. Usually 18, 16 gauge, 14 gauge, down to about 11 gauge. That's about what's usually done with low carbon steel. Okay, and when you're doing low carbon steel, when you're welding low carbon steel like that thin, you can weld things like the butt joint back here with no joint preparation or anything. You can do it with just a square edge. Okay. Now, one of the best ways to learn to do this is to first start carrying a pool without filler rod. Okay, and that will teach you to move the pool along without burning through the plate, and to continue moving the pool without leaving it, keeping it the right temperature, a nice molten temperature. Okay. If the pool has been moved at a proper rate, it'll show a weld with real closely formed ripples of uniform width once you're done. And you don't want to have any holes in it or anything like that. Okay. You want to hold the torch within about 1/8 of an inch of the surface of the plate. You'll start noticing the puddle melt, and then you just start moving it along, just sort of manipulating the torch around, keeping that puddle a consistent size, consistent width, and hopefully without burning it through. Probably going to burn a few through at first, though. That's okay. Okay, then you'll start making beads with filler rod after that. Okay, flat position is where you'll start. Okay, basically you set up your whole system, get all the equipment set up and everything. Light the torch, adjust it for a neutral flame. Hold the torch tip so that's at an angle of about 45 to 60 degrees with the plate, okay? It'd be probably somewhere like that. Hold it in your right hand, tilt it in your direction of travel, your filler rod in your left hand, coming in from the other direction, okay? You want to heat an area about a 1/2 inch in diameter up to the melting temperature. You'll see it start to melt. You'll get real glassy looking, almost like a mirror. Okay, then as you're moving your puddle along, just like you did back when you were doing it without any filler metal, you'll just start moving that puddle along. Only now you're going to start dipping your filler metal into the puddle as you're moving along to add a little extra filler to it. Okay, and you want to always make sure you dip the filler rod into the puddle. Don't let the rod stay above the puddle and drip down into the puddle. It fills up with oxidization and everything. It makes for a real brittle, nasty weld if you do that. Okay, remember to keep that cone on the inner flame within about 1/8 of an inch of the plate. 1/16 to 1/8 of an inch is usually the best. Okay, you'll move it along. You'll get the nice uniform width, the nice even ripples, and stuff like that, and that's all there is to it. The only other thing after that is just learning to do it in the different positions and with the different joint configurations. Some of the joint configurations, like the corner and the edge, can actually be done without filler metal, okay? But for maximum strength, it's recommended that you go ahead and use the filler metal with them. Square butt joints, like I said, on sheet metal, when you're doing stuff that's 1/8 of an inch or less thick, then you can just go with a square butt joint, like you see on the bottom down there. There's no doesn't require any beveling or any preparation to that joint whatsoever. You'll just have to leave a little bit of a gap to give you a room to push your filler metal through for a full penetration weld. You should always, when you're welding a butt joint like that, you should always make sure that the joint crack stays in the center of the molten puddle, center of the bead, and the plate edges are completely fused, and the penetration must extend through the root, which means that as you're welding along, you want to pop a little hole in between the joint edges. This is called a keyhole, and it'll open up and it'll round out, and that gives you an indication that your edges are breaking down and fusing completely, and that you're pushing filler metal through to the back side. And once again, the reinforcement, in other words, the cover and the back side, should not exceed more than about 1/16 of an inch above the surface of the base metal. Okay, welding a lap joint, like this one up here. Okay, you're actually using what's called a fillet weld. In other words, you're welding in a corner up there. You'll be welding it right here. And if you can do it, sometimes it's hard to get down in the corner with the Oxy Soldin. So if you're looking for maximum strength, if you can do it, you want to probably weld it on both sides of the lap, okay? And that will also prevent it, because once you weld, if you only weld on this side, this is going to start, the weld is going to start shrinking, and it'll start actually pulling it apart on the back side. So if you can weld it on both sides, that'll give you maximum strength, and that's the most desired, but in a lot of applications you might not be able to do that. So welding a T-joint, that's also a fillet weld style right there. And that, with Oxy Soldin, you can weld one side, but it's really hard to weld both sides. What happens is you get so much metal built up on one side that you almost can't generate enough heat on the other side to get it to melt properly. So you'll just do one side of that one. Okay, now they actually do heavy plate and pipe with Oxy Soldin too. And they do it with a high test welding rod, okay? And it's kind of a different animal. You have to use big tips, big everything, higher pressures on your oxygen and stuff like that. Okay, but it's not. I mean, it's gotten quite uncommon anymore, but it's still actually done in places. Looks to me like that's about all we're going to have in this chapter. Okay, so go ahead and read this chapter thoroughly. There's some stuff in here on some of the tables and things that may be on the test that you may have to know, so make sure you read it thoroughly. Okay, and good luck on the test.